Hello, everyone, and thank you for joining us for Building a Better Data Lake with Talend Databricks. My name is Michael Destine. I'm the Director of Technology Alliances at Talend. And with me is Cameron Davey, a Solution Architect in the Technology Alliances group. Today, we're going to go through talking about how to build a better data lake. And I will walk through kind of the concepts, and Cameron will give you some demonstrations. First, let me talk about Talend, just give you a quick overview of who we are. We are a leader in the data integration and data integrity market. We're well placed in the Gartner and Forrester analyst reports. We have over 4,000 customers across all different verticals all over the world. And we have deep partnerships with the key cloud vendors like AWS and Microsoft, as well as with Databricks. We have offices around the world, and we support key cloud locations, both in AWS and Azure. Now, Talend, the main product that we provide is something called Talend Data Fabric. And when you think about the data world, it's a bit of chaos out there. There's hundreds of different source systems and applications where data might be coming from. And so how do you really manage that chaos? Well, first you have to collect the data into one central repository, namely a data lake. Then you need to govern that information to make sure that only the right people are having access to the data, and also that you're applying the enterprise standards on how to form that data and how the data should be collected and published. You might need to transform that data into a common data model and then share it with other users. And Talend Data Fabric provides the comprehensive tool set to do that. And it supports all different roles within the data team: the data architects, integration specialists, data scientists, stewards, citizen integrators, and business analysts. And from multi-cloud to on-prem, we can support whatever deployment option you'd like. Now let's think about what a Delta Lake is. So building the Delta Lake, as the reference architecture really specifies, there's kind of three key areas in which you would store your data. There's the ingestion tables, which Delta Lake calls the bronze tables. There's the refined tables, known as silver, and the feature engineering and the aggregated data store called gold. So utilizing this reference architecture, the key question then becomes, how do you get data into those various items and get them prepared and ready to go? The first one is sourcing the data from streams and batch and applications. And so the first thing Talend will be able to do is help you ingest that data into a raw zone so that you can get those bronze tables. The second step is how to refine that data into those silvers tables. How do you curate the data with common schema and standardized quality? And lastly, taking that data to the machine learning world requires another level of transformations, and this is called feature engineering. So we'll talk about how Talend can do all three of these. Let's first talk about bronze. Talend provides two options to ingest data into your Delta Lake. The first is our SaaS-based option, and this is ideal for sales and marketing SaaS applications. This is a fully SaaS-based environment available through the data ingestion network on the partner gallery menu in your Databricks console. The platform, as I mentioned, is fully SaaS-based, so there's nothing to install, nothing to run. It takes care of it for you. You just set up your schedule and the orchestration of how you want the data to, where you want it to come from, and how often do you want it to be loaded in. Now that platform is SOC 2, HIPAA, and GDPR compliant, so you can be assured that you're going to follow all of your enterprise standards. And it auto scales and has enterprise SLAs. Now, what it's really famous for is being able to connect to those SaaS applications, as I mentioned. It has over 100 different connectors, and it also has an open source connector kit that allows the user to build any of their own. And customers that select our enterprise contract can add a custom connector as part of that agreement. But as you can see, it's applications like Workday, Salesforce, Facebook Ads, SendGrid, Square, Eloqua, and so forth. Now, that covers all the SaaS applications. But many of you also have legacy systems, whether those be old IBM systems or traditional enterprise ERP applications and other on-premise applications and systems. For that, we would use our ETL option, which provides through something called Talend Studio. That can be an on-prem or a cloud-based environment. It offers the bulk extract and bulk load capabilities. In this case, they're usually read and write connectors, so you can do multi-directional integration. And it has support for Kafka and queues. Again, it's SOC 2, HIPAA, and GDPR compliant, so it'll meet your security regulations. Now here, the applications and the connectors that we connect to are your more traditional enterprise applications, SAP, Oracle E-Business Suite, as well as key on-premise systems like Kafka, MySQL, and Teradata and other databases like MemSQL. So this provides you two different options to load the data into your Delta Lake depending on where the data is coming from. Cameron, can you give us a little overview of that from a demonstration perspective?
Right, so let's take a look at what that looks like to integrate data from the SaaS application side. So here we have within the Talend Stitch data loader environment. And here I want to be able to set up what it looks like to connect into Delta Lake on Databricks. In this case, I don't really need a ton of configuration for this. In fact, very little. Really, all I need to do is select the fact that I'm going to select a destination. In other words, my data is going to be extracted and landed into Delta Lake. And then I'm going to set up the JDBC URL endpoint of where I'm going to connect into and my bucket name along with my access token. And that is essentially all I need to be able to provide for connecting into Delta Lake on Databricks through Talend Stitch Data Loader. I do have to do some setup on the AWS side as from a security standpoint, but that's all of the configuration that I need to do. From there, I will have that integration ready to go. And in our particular example, we have one that loads from an Azure data set and lands that into Delta Lake. And we also have an example that loads from Salesforce, the classic SaaS application, and lands that data into Delta Lake as well. So we've talked about the SaaS side of things. Now let's look at what it looks like to integrate data from the on-premise or legacy side of things. So as Mike mentioned earlier, we would use Talend Studio to connect into those on-premise or legacy data sources. So in this particular example, I have a very simple example because landing data into Delta Lake at that bronze level is very simple. I have my source and I'm going to map it into a target. That's it. So in this case, my source is an on-premise Oracle data warehouse that I'm connecting into via JDBC. I have my Azure Databricks environment set up and established down below. And all I want to do is be able to drag that in. To start with, I'm going to start on the right-hand side by grabbing those components that I'm going to drag and drop onto my canvas. So I found the Delta Lake output component. I've dragged it onto my canvas. I've configured my Databricks system, my cluster down below, and that's all I need in order to run that particular job. Extracting data out of my on-premise data warehouse and landing that into Delta Lake. Mike.
So now we've solved our bronze tables. We've loaded those tables up with all the raw information, and that's really your landing zone for the data. Now what we need to do is combine multiple data sources together. And to do that, we'll be coming back into Talend Studio, which provides that graphical layout and data flow environment to design the data flow, connecting the data together. Now that's going to provide a lot of transformation capabilities to structure the data from the source applications into a target system. But then you're going to look at how's the data content structured. Is it meeting the data quality rules? Is it standardized? Do we have duplicates and so forth? And so for that, we provide the profiling tools to be able to understand what data is available and how's it formatted, as well as all the data quality functions to transform that into a common content. Now, often that work needs to be done by a business analyst rather than a data engineer, because who's better at deciding what the good data quality is? It's the business analyst that's very familiar with the data. So for that user, we provided a web-based, spreadsheet-based UI to be able to understand what is the current state of the data, and then provide an easy way for them to apply rules to configure that data to meet their enterprise standards. So with that UI, that user is going to be able to define what's called a recipe to say, this is how I want the data quality applied. And then they submit that recipe back to the data engineer who puts it into the data flow for enterprise operations. Now, sometimes there's going to be situations where the data engineer is not going to have a flow that's going to handle the correct information. And even the business analyst might not have anticipated certain problems. And so when those types of errors occur, we route the data set out to a data steward who's going to manually review the data, potentially correct it, and then resubmit it back into the data flow. And so we provide a specialized UI for that data steward as well. Let's take a look at the data integration side of it for the data flow, as well as the data preparation side for the business analyst. Cam?
Great, thanks again, Mike. So in our particular example, we've moved off of simple ingestion. That was bronze, and now we're working into transformation. That really is what starts to define these silver tables. And we're starting with the use of the various data privacy, data quality, survivorship, standardization rules, and components that are available within the Talend Studio palette. So highlighted in red on the right-hand side are all of these various components. And this is just a short sampling of the various components that we have. Once I've done that, I can add those, drag and drop them directly into my existing workflow. In this particular case, I'm extracting out of Shopify and some SFDC data, and I'm landing this, and I'm using Spark SQL to be able to extract that data out. And now I have those different rules. In this case, I've got a verify email component and a survivorship rule component that are added directly onto my job workflow here. My sources have been brought in, as you can see on the left-hand side, and I'm going to run those through those various data quality components to further clean my data. Now, as Mike mentioned earlier, we also have this interface to be able to allow the business analyst or data analyst, somebody who is much closer to the end result of that data, to be able to interact with that data as well. That user logs into Talend Cloud, as we've seen here, and that user is going to come up to the menu and is going to choose data preparation. As Mike mentioned, we want to be able to allow this business analyst or data analyst an interface to be able to prepare data or to define a set of rules for how this data should be cleaned, verified, quality checked, etc. So in this case, I have my list of functions, if you will, on the left-hand side, the ability to define the connection into my data source, the ability to define what data set I'm going to extract, and then the ability to now prepare a data preparation or a recipe. And that's what we're going to do now. So I'm going to add a preparation and launch into that. Now with this data set that we see here, this is the raw data. It has not been transformed yet. And I'm going to take this tool and use it to be able to prepare that definition or that set of rules, a recipe, if you will. Now, what you'll notice, first of all, is that there is some orange highlighted on this, and that is indicating that that data is either incorrect or malformatted. And so that's what we're going to use as our guideline to be able to change how this data is going to look. Now I can start on the right-hand side. I've selected a particular column, this job industry, and I can use the suggestions or this ever-growing list of preparation functions that are available for me to use to change this data, to check the quality of the data, etc. So again, I've selected the job industry as my first column, but I can go through any and all of these columns to change that data. Now we see the result of my finished preparation, if you will. Now on the left-hand side is where I have developed my whole set of instructions or my recipe for how I want this data to change. So it's not just simply change one column. I have in fact 10 different steps to this column that are all baked into this recipe. And now, as you can see here on the top of my bar, it's actually showing no more orange, because based on how this preparation will transform this data, I've got that data down to looking clean, solid. Any of the gray lines indicate simply null or blank data, and that's okay. What we want is clean data that does exist, and that's what the green bars indicate. So we have identified that we have cleaned this data up quite significantly based on what it used to look like.
So really what we have at that point is data that's really good for business intelligence. We've combined the data into a common schema, and we've improved the quality of the information, standardized it, and made it ready for consumption for reporting and business intelligence. The next step then is, let's look at what does a machine learning need. Machine learning is going to want the data in slightly different formats. So much like data quality is to business intelligence, feature engineering is to machine learning. With machine learning, you're going to want to transform the data to make it optimized for those algorithms. So one common example we see is, we saw those job classification codes in the prior table. Now, often in a machine learning world, it's not, you don't want to look at one column that has all the different job classifications, but rather you're going to want to have a separate column for each classification there. So we had, financials as one of them. And so you would have a 0 or 1 to indicate if it's financials. Second one might be retail, and so forth. So what we can do is use the binarizer function in that case to transform the data into those various columns. Now this is just one example. As you can see here, there's dozens of functions available to make the data ready for machine learning through the feature engineering process. So Cameron, why don't you give us another example of how you've applied that to the data flow that you've been creating?
Absolutely. So if we take a look at sort of the further build out of this sample job, and I think Mike touched on this at the beginning. So we have data already available, if you will, or ready for the BI or the business intelligence use case. And that's the top track of this job. You can see that we've actually spliced this job, the data for this job, into 2 different areas. So I don't need to do anything as far as extra for my BI folks, but for my data engineering folks and my data science folks, I want that additional capability of adding in with additional feature engineering, more machine learning capabilities, et cetera. So that's what the bottom track here is, if you will. The first thing that you'll notice is that I've added in that data preparation run that we showed in the last step, but now I've added in additional capabilities as well. So again, on the right side in my palette, I have all of these different data quality, data privacy, machine learning functions or components that are available for me to simply drag and drop on to my canvas. That's what we've done here. And the one in particular that we focused on is the T model encoder component, which I've highlighted down below. So that's just one example of that. Mike talked about the binarizer before. That's another example with these different transformations. So I've selected in this particular example, one column. It's going to output the customer number, and I can use that and use some transformations directly within that data set. So I can tokenize it, index it, based on if it was a string or not, a whole host of different components. And those are all available directly in that palette that we see on the right-hand side.
Okay. So what we've done is we've built a data flow. So the data engineer has walked through how to get data into the bronze tables, how to refine the data into silver, and how to optimize it for machine learning into the gold. Now the question becomes, how do you deploy and run that? So what Cameron showed you so far was really step 1 in this process, using the design surface to develop that data flow. Now what happens next is that when you go to deploy that, we're going to convert that data flow, that graphical flow of information, into native Spark code. And so we're going to use our code generator and take that code and put it up into the Talend Cloud, into the repository, stored as an object ready to run. And then we can set a schedule for how often and when do you want to run that. When it comes time to run that job, we will push that code out to your Databricks cluster. It could be an interactive cluster, or it could be a data engineering cluster. You get to decide. And then that job is going to run as native Databricks code within that cluster. Cameron, you want to show them how to set that up?
Absolutely. Very easy to do, which is the good part here. So we've developed our job, our workflow, as Mike has mentioned, and now we want to be able to deploy that. So very easy to do. I, first of all, have defined the Databricks cluster on which I want this to run. Very simply, we've talked about this earlier. Endpoint, cluster ID, and a token is really all I need in order to define where I want this job to ultimately run. In order to do that, I'm going to simply right-click on the job's name in my Talend Studio and hit Publish to Cloud. That will use the credentials that I've added into Talend Studio, which is basically my username and password to Talend Cloud, to my Talend Cloud account, and that will publish this job to my Talend Cloud account in order for me to be able to run it in the cloud. So how do I access that? Well, then I come back to Talend Cloud. We saw this earlier with data preparation. We're logging in now. We want to get into the next phase of running this job or publishing this job. So same interface as we saw before, but now I'm going to go ahead and click on the management console for Talend Cloud. And that is going to give me access to all of the different management capabilities of Talend Cloud, all focused around the running and management of those jobs. So I've got my operations, my management, all of the projects, etc. I want to be able to view tasks and plans because that's where I'm going to go ahead and run a job. So on here, I have all of my various jobs that I have loaded in the past. The top one is the one that I just uploaded to Talend Cloud, and I want to be able to add a new task or essentially a run cycle for this job. So I'm going to go ahead and hit add, and that will run me into adding a new task for this particular job. In here, very little configuration necessary in order to run this job. Remember that the definition of the job tells the job to go and send this native Spark code to that particular Databricks cluster when it runs. So I don't even need to worry about setting that up in here because that's already defined in the job. Here I just define what I want to run, where I want it to run. So this is my personal workspace within Talend Cloud with that artifact name, and I go ahead and run it. From here, I define where I want it to run. So I want it to run in my cloud runtime. And then I define if I need to do any type of logging. And then finally is when or how often do I want this job to run. So if I do it manually, it just means, okay, go ahead and run it now. Or once, and I define at a later time, or based on any of those others, I can set a recurring schedule for when I want this job to run, including on a webhook, which means I get external web-based input as to when I want this job to run. And again, no matter what the option is, what Talend Cloud is doing is compiling the code, Spark code, and sending it to Databricks for it to run whenever I decide I want that job to run.
So to summarize, we support Databricks on AWS and Azure Databricks. So regardless of where your public cloud is, we can support you. That native code Spark generator provides for very high performance and very tight linkage to your Databricks environment. And more so, we support, have full support for Delta and the time travel. Cameron might have showed this earlier, but we touched on it a little bit. We do support Spark SQL, so you can, mix and match your cloud data warehouse in there. And as I mentioned earlier, we support both interactive and data engineering clusters, and from a performance and management perspective, supporting data sets and data frames. So to summarize, Talend provides a ready-to-run integration platform as a service. So all of that capability is cloud-based and ready to use at a moment's notice. It's delivered as a data fabric, and what we mean by that is that one platform to support all of those different functions, whether it's ingestion, whether it's data integration, data quality, data preparation, data stewardship. And we didn't even have time to talk about our data catalog capabilities, but those are there supported as well. And all this is ready for you to try. So go to info.talend.com/request-talendcloud.html, and you can get started on your cloud journey with Talend and Databricks today. From Cameron and I both, we thank you very much for your attendance.